This is SpaceTime Series 27, Episode 148, for broadcast on the 9th of December 2024. Coming up on SpaceTime, another delay for the first manned-moon mission in half a century. The discovery of ancient hot water on Mars, pointing to a possible habitable past for the red planet. And Europe's Eclipse making double satellite Proba-3 successfully enters orbit. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
NASA have delayed the planned launch of their Artemis 2 manned moon mission until April 2026. The flight, which was slated for September next year, has been put back 6 months because of ongoing concerns about the ablative heat shield on the Orion spacecraft. The postponement means the Artemis 3 mission, which will see humans return to the lunar surface, will now not take place until at least mid-2027. That was supposed to launch in September 2026. The 25-day-long unmanned Artemis 1 mission sent an Orion spacecraft to lunar orbit and back again to Earth. And while everything appeared to go well during the flight, post-mission analysis revealed that Orion's heat shield wore away more unevenly during the re-entry into Earth's atmosphere than what was originally predicted. NASA Administrator Bill Nelson says temperatures inside Orion remain near normal room temperature, meaning crew would have been safe were they aboard. But engineers still want to determine exactly why the heat shield burned away in such an unpredicted manner. We know the uneven ablation was a consequence of Orion's skip re-entry trajectory. This involved the capsule deliberately bouncing along the top of the atmosphere several times before finally re-entering. The manoeuvre was needed to dissipate the tremendous amount of energy associated with high-speed returns from the moon. NASA's Deputy Administrator Pam Melroy says while the capsule was dipping in and out of the atmosphere as part of the planned skip re-entry procedure, gases generated inside the heat shield's ablative avcoat outer layer were not able to vent and dissipate as expected. This allowed pressure to build up and cracking to occur, and that caused charred material to break off at several places of the outer layer. Milroy says simulations suggest Orion's heat shield will protect astronauts on the 10-day Artemis 2 mission, negating the need to develop a new version. But mission managers will alter the re-entry trajectory in order to minimise the issues uncovered during the Artemis 1 return. So, for Artemis 2, that means engineers will limit how long Orion spends in the temperature range in which Artemis 1's heat shield phenomena occurred. They'll do that by modifying how far Orion can fly between when it enters Earth's atmosphere and when it lands. The revised trajectory means Artemis 2's Orion capsule will now come down in the Pacific Ocean closer to San Diego than what was originally planned. Other issues being looked at include the performance of Orion's battery and its life support environmental control systems. The Artemis 2 issues will cascade onto the Artemis 3 timeline, which will likewise be delayed. And there are additional problems for Artemis 3. It needs to wait until SpaceX's Starship mega rocket's ready for manned flight. NASA will be using a modified version of Starship called the HLS to dock with Orion in cislunar orbit and then carry 2 of the Artemis 3 crew down to the lunar surface. They'll remain there for several days before returning to cislunar orbit and then redocking with Orion for the return journey to Earth. After that, the HLS version of Starship will be used to regularly transport Artemis crew and equipment between the Gateway space station, which is yet to be placed into cislunar orbit, and the lunar surface. Needless to say, as developments occur, we'll keep you informed. This is SpaceTime. Still to come, a new study has uncovered what may well be the oldest direct evidence of ancient hot water activity on the red planet Mars. And the European Space Agency's Proba-3 spacecraft has successfully achieved orbit insertion following its launch aboard an Indian space research organisation PSLV rocket. All that and more still to come on SpaceTime. A new study has uncovered what may well be the oldest direct evidence of ancient hot water activity on Mars. The new findings, reported in the journal Science Advances, adds more evidence to the hypothesis that the red planet may have been habitable sometime during its ancient past. The research analysed a 4.45 billion-year-old zircon grain from the famous Martian meteorite NWA 7034, also known as Black Beauty. One of the study's authors, Aaron Cavosi from Curtin University, says nanoscale geochemistry was able to detect elemental evidence for water-rich fluids. He says that opens up new avenues for understanding ancient Martian hydrothermal systems associated with magnetism as well as the planet's past habitability. Cavosi says hydrothermal systems were essential for the development of life on Earth, and these findings suggest Mars also had water, a key ingredient for habitable environments during the earliest history of crust formation. Through nanoscale imaging and spectroscopy, Cavosi and colleagues identified element patterns in a unique zircon crystal, including iron, aluminum, yttrium, and sodium. These elements were added as the zircon formed 4.45 billion years ago, suggesting water was present during early Martian magmatic activity. An earlier 2022 Curtin study of the same zircon grain found that it had been shocked by a meteor impact, marking it as the first and only known shocked zircon from Mars. The new study took Cavosi and colleagues a step further in understanding early Mars, by way of identifying telltale signs of water-rich fluids from when the grain formed, thereby providing geochemical markers of water in the oldest known Martian crust. Cavosi says the research shows that even though the Martian crust endured massive meteor impacts that caused major surface upheaval, water was still present during the early pre-Nochian period, prior to about 4.1 billion years ago.
Black Beauty continues to amaze scientists around the world. It's a very unusual Martian meteorite, different from all the rest. Most Martian meteorites are fairly normal igneous rocks that you might find also on Earth, like basalts from Hawaii and other places like that. Black Beauty is quite different because it contains some of the oldest materials known from Mars. Many of the rock fragments and minerals in Black Beauty have ages that go back to about 4.45 billion years, nearly 4.5 billion years old, which is vastly older than in any other Martian meteorite that's available on Earth.
It's vastly older than most Earth examples of rock too, isn't it?
Let's just underline that. It's older than anything ever found that's a part of Earth.
Quite amazing.
So it's if you want to study the earliest history of either Earth or Mars, there's very little materials available to do that. And in the case of Mars, Black Beauty has a lot on offer from that point in time. Some people have a funny distinction about whether it's the oldest Martian meteorite or not. And there's a little confusion there because the materials in Black Beauty are the oldest piece of Mars, hands down, with no second place in the race. But it's a funny kind of a rock called a breccia. Some people call it a regolith because it's basically broken up fragments of rocks and minerals that were brought together after they formed. So it's not like a basalt that formed at 4.45 billion years ago, like most other Martian meteorites. Of course, they're much younger. And so it has much longer of a history on Mars where things happen to it. It's not exactly clear when all of this material came together as a coherent rock, because if you think of all of the broken up bits of rock that you might find out in the bush, those are all kind of loose particles until they get buried and over time become a coherent rock. Black Beauty's hard. You have to use a saw to cut into it. And so we know that all of these pieces and all of these parts ultimately got glued together. What's amazing is some people think a giant meteorite impact may have accomplished that job perhaps 1.5 billion years ago. There's evidence that at that time, which is much younger than what our study focused on, but there's evidence that the meteorite and its components were all affected by a lower temperature fluid alteration event at that time. But even 1.5 billion years ago, the meteorite still had a long time to go because it was only blasted off the surface of Mars probably 5 or 10 million years ago, which is the best estimate for when it was ejected from Mars and fortunate enough to have a trajectory that crossed Earth where it landed in the desert. So it's not the oldest meteorite on Mars. That actually has a distinction from the famous ALH 84001 rock, which is a whole bunch of numbers most people won't recognize. But
I know that one.
It's the famous meteorite that, when it was first announced, had a claim that there might be some evidence for life in it back in the late 90s.
This is Allen Hills in Antarctica where this one was found.
Correct. The thing about that rock is it's a proper igneous rock that formed at about 4 billion years ago. And so it's the oldest sort of rock that formed during an event on Mars, even though lots of things happened to it since then. Anyway, the Black Beauty allows us to go back further in time, which is why we studied it.
Now, one of the interesting points about Black Beauty is you were able to date it very precisely, looking at zircon crystals. That was uranium to lead.
That's right. We've actually been studying this chip of Black Beauty for several years now. We published a paper in 2022 that I think you and I had a chat about.
Yes, we did.
That was when we actually first published the age data and some other evidence that convinced us that the zircon in question had been affected by a meteorite impact. And so the age dating we did at that time was involving uranium and lead to determine when the isotopic clock of this crystal started ticking. And that gave us a number of 4.45 billion years, which clearly got our attention. It was quite old. We weren't the first to discover zircons that old in Black Beauty. There's a population of zircons with similar ages. They span about a 50 million year time window from about 4.48 billion down to about 4.43. So those decimal points define a period of time of about 50 million years when there was magnetism in the Martian crust. And so that was known previously, and our zircon fell right within that time window. The difference between what we reported 2 years ago was we found evidence that this zircon had been affected by shock waves from an impact. In other words, it was a shocked zircon, and that was an unusual find in Black Beauty. Many other studies on Black Beauty have proposed that many of the rock fragments that are in it, there's all kinds of different bits and bobs of rocks. And many people have shown that these fragments, a great majority of them, are also of similar age, about 4.45 billion years, plus or minus just a wee bit. So they're old. And beyond that, people have proposed that the igneous rock class themselves were made as a consequence of melting from meteorite impact. In other words, when big space rocks were slamming into Mars nearly 4.5 billion years ago, they triggered the melting that ultimately formed these rock chips. And the rock chips, of course, must have been blasted apart by later impacts, because here they are as small kind of centimeter-sized fragments that are all stuck and gummed together in this meteorite. So it's a fascinating potpourri with evidence of early impact events. The difference in the zircon that we found is there's evidence within the crystal for a shock event, and so that was the first time that had been recognized in the mineral zircon originating from Mars. So that's what got us onto this grain, and very excited about it 2 years ago.
This is around the same time, within a couple of million years, of when the Earth was formed through the impact of the proto-Earth with a Mars-sized planet, and the result of that, of course, was the creation of our moon, the Earth's moon as well. This is really early in the evolution of our solar system. In fact, to get rocks that are much older than this, you're looking at carbonaceous chondrites, which originated in pre-solar grains before the solar system was formed.
That's right.
That's how old these things are.
It's hard to go much further back than this, because we're brushing up against the primordial time when planets came together. And so if you're talking about the age of a planet, most meteorites and our solar system is approximately 4.56 billion years old. And so we're talking about material that has survived these zircons in Black Beauty from no more than 100 million years after that. And if 100 million years sounds like a lot of time, geologically it's a blink of an eye. So this is very close to the beginning, yes.
And as you've continued to examine these zircons, you found something else. You found evidence of what we'd call hydrothermal activity. Tell me about that.
Well, this is the focus of our new study. And again, we have sat and thought carefully about this zircon over a number of years. And oftentimes when you find something in science, it's reproduced eventually by other people, which is a good sign. But our discovery of the shock zircon is fairly recent. It's only from 2 years ago. In the meantime, there have not been any additional ones reported. And so we thought, well, let's go see what more secrets this grain might contain, because it's unusual. From my point of view, it's the most special mineral from Mars because there's only one of them right now. Eventually, people will find more. But for the moment, it's a very unique zircon that records a history that's not recorded in any other zircon from that planet. So we wanted to take another look at it. It's helpful to put size in perspective here because these zircons are tiny. This one's about half the width of a human hair, so it's small, but that's okay. We're quite good at working on and analyzing little things. It's interesting, though, that many of the zircons we found in Black Beauty are even smaller. So this wasn't the smallest one there. Many of them are even littler, but because this grain was the size that it was, it allowed us to go in and do some additional analyses. Now, this time we wanted to focus on trace elements. I mentioned uranium a moment ago. That's a trace element too. If we think about what zircon is made of, it's a pretty simple mineral. It really only has 3 elements: oxygen and silicon and zirconium. But the way these elements bond, the way these atoms bond in zircon, it leaves space for other elements to sneak in the back door, but at a low abundance level. Hence, we call them trace elements. Of course, one of them is uranium, which is a really useful one because over time it decays to lead and it forms the basis for the isotopic clock that we use for dating. And so that's a helpful one. But uranium's not the only element that can sneak in the back door. Others do as well at low levels. What we were surprised at when we did the analysis was we were able to analyze the surface by scanning over it with a fancy method called time of flight secondary ion mass spectrometry. They call it TOPSIMS for short. And what it did was it analyzed the composition of what elements were at across the entire grain, and it produced a map. And the most fascinating thing was we found that the elements iron and aluminum and sodium showed layers that were regular in the zircon, much like you see when you slice open an onion. And they were growth zoning, and meaning they appear to have a regular pattern that was defined by the growth of this mineral when it formed. The problem is those elements, iron and aluminum and sodium, are not normally found in zircon. And so that threw us off guard. In fact, it gets even worse because those elements are often the elements that when people detect them in zircon, it indicates that the zircon has kind of started to go rotten, meaning the radiation in the crystal has produced local damage, breaking the bonds, and then water and fluids can enter the crystal and deposit these elements long time after the zircon formed. And so when we first saw this, we scratched our heads a little and we said, we better check to make sure that the zircon isn't damaged from radiation, internal radiation. So we applied another technique, transmission electron microscopy, or just TEM for short, and it actually allowed us to take a look at the individual atoms in the crystal, and we found that they were beautifully ordered, they were beautifully regular, that there was no damage that we could detect. And so at the atomic scale, this zircon was fully crystalline. In other words, those elements that we detected, the iron, the aluminum, the sodium, and whatnot, they didn't come in later. You can't get those elements into zircon after it crystallizes if it's a crystalline material. Zircon's very tough and robust. And so it was an indication that, wait a minute, we have this nice pattern of growth, and the zircon is fully crystalline. What's going on here? What kind of environment did this zircon grow in? And to find the answer, we had to look back to Earth. Well, on Earth, zircon's not a rare mineral. It's quite common. It's studied heavily for dating rocks and other things. In fact, when you go to the beach and have sand between your toes, many of those sand grains will be zircons because they survive erosion and transport down to the rivers and the ocean. So zircon has been analyzed a lot, and trace elements in zircon have been analyzed a lot. There have been thousands and thousands of studies, and yet this feature for these elements is not common. In fact, the only place we were able to find an analogy on Earth is, interestingly enough, from South Australia at the famous Olympic Dam ore deposit, where that's a copper and uranium and gold mine that formed about 1.5 billion years ago. And about 5 years ago, a study was published, in part with our collaborator at the University of Adelaide, that took a look at elemental zoning in some of the zircons from the Olympic Dam deposit. She found that the zircons at that site had the nice regular elemental zoning of iron and aluminum and other elements. The key observation here is that those granites formed during hydrothermal processes. So the zircons were forming and crystallizing in those granites when hydrothermal fluids were present. And it was actually the action of the hydrothermal fluids and alteration that ultimately concentrated the ore bodies, but also delivered other elements that were available for incorporation into these zircons. So when we made this observation that here's an environment on Earth where zircons that form under hydrothermal conditions have this unusual regular pattern of zoning in these elements that are not normally found in zircon, we thought, aha, we have a lock. We found a match. And to be honest, it's not that unusual of a process. There's always some amount of fluid associated with igneous rocks. But in places like at the Olympic Dam deposit, the intensity and the action of those fluids was sufficient to change the composition of the minerals. And of course, it created an ore body during that same process too. The idea here is that these magmas heat up waters and fluids that are present, and they get very hot, and they literally move through the rocks like a sponge and can carry all kinds of elements with them as they go. Swinging this back to Mars, this was a key observation because we know when the magmatism happened on Mars. We get that from the uranium-lead age of the zircon. So this is a process that involved hot hydrothermal fluids, and we know what was occurring at 4.45 billion years ago, nearly 4.5 billion years ago, and it pins fluids in the Martian crust at that time, and we found that very exciting.
That matches up with other studies which suggest that the Martian magnetic field would have been important for retaining the planet's atmosphere. Once the core solidified and the magnetic field disappeared, that's when the solar wind from the sun and cosmic rays and things like that were able to erode the Martian atmosphere away, and as the atmosphere eroded away, the water evaporated as well.
There's all kinds of secondary implications and processes that fall out of our observation.
Yeah, the timeline's exquisite, isn't it?
Many of which you just mentioned. There's a question here. Do the observations of hydrothermal processes in a zircon, can you say there was stable liquid water from that? And the answer is no, but there probably was. The idea here is that if there was fluids coursing through the Martian crust at this early time, they ultimately would have escaped to the surface. Now, whether they would have ponded at the surface in terms of making stable surface waters or escaped and contributed volatiles to the early Martian atmosphere, all of those outcomes are very possible. In fact, probably they are probable more than possible because that's what fluids do. We don't know what the exact trigger for the magmas was. Was it internal heat release from the interior of Mars, or was it impact-driven? Because we have evidence, quite a lot of evidence for impacts in this meteorite. The zircon itself records an evidence of impact. That must have happened after the zircon formed because it felt the shock wave. And then there's all these other bits of rock that are attributed to have formed as a consequence of impacts hitting and causing melting. So there's lots of issues around what triggered the early magmatism. There's also questions around what's the source of the volatiles or these hydrothermal fluids just from the interior of Mars volcanically outgassing during magmatism like the one that made this zircon.
Take it the impact site for the asteroid impact which caused Black Beauty isn't all that far from the Tharsis Rise and Olympus Mons and places like that.
That's right. But there's also an alternative that some of the fluids that we may be detecting were delivered by some of these large impactors and that they were impact-driven hydrothermal systems in the Martian crust. So there's quite a few scenarios, all interesting, that these data provide some control points for. There's even a proposal that I find fascinating that was from a study published about 20 years ago that examined the ratios of iodine and xenon isotopes between the Martian atmosphere that has been measured by space observation and Mars's mantle. And of course, that's data from meteorites. And the observations were a mismatch for many of the Mars mantle measurements as compared to the Mars atmosphere measurements. And the explanation that was put forth for why these iodine-xenon ratios were different was because they're two elements that are a bit challenging to change, to fractionate and change the ratio from one another. And those authors put forth that the easiest way to do this is if a global ocean existed on Mars within 100 million years of it forming. And so this would have put it conveniently at about 4.45 billion years. In other words, the same time as the magnetism that we are measuring in this meteorite. So our data don't provide evidence for an ocean on Mars at that time. That's a bit of a stretch. But it's interesting that it coincides with proposals for an early ocean because the way that the iodine and xenon as released from the mantle would have passed through the water, that's what would have changed the ratio. That's why it's easiest explanation to consider, but it's not from direct observation of anything having to do with water. It's an ocean solves a geochemical problem for two elements that most people don't even spend much time thinking about, but they're important to try to solve the Martian puzzle. So it's very possible from some points of view that there may even have been quite a bit of surface water at the time that we're describing.
That would explain the Martian lowlands in the Northern Hemisphere.
Well, there's that too.
The other interesting point about all this, of course, is once you start talking about hydrothermal activity, here on Earth, of course, we know that hydrothermal activity is associated with early life forms. Archaea love hydrothermal vents, places like that. They are one of the earliest known life forms here on Earth. There's fossilized chemical evidence suggesting that some geological structures at places like the Atacama High Desert shows evidence that these may have led to the formation of the first microbial mats and possibly the first life forms on Earth.
It's impossible not to start connecting pieces that are on a chessboard into a framework. As far as our work, we can't cross a bridge and say, we analyzed the zircon, we found evidence of hydrothermal processes, this means life. So I'm cautious about that. However, what we can say definitively is if there was warm waters in the crustal rocks of Mars, then that would have provided a wonderful habitat or a habitable condition for any forms of early life. And then the parallel thought is, right, let's turn our attention to Earth, where scientists think fairly conservatively that there's not a lot of question about life back to, let's say 3.5 billion years ago. We have stromatolites that are fairly complex forms that are preserved. Some people think the stromatolites go back to 3.7 billion years. There's other chemical evidence for even older possible action of life. So all of a sudden, we're getting back into the realm of time on Earth, where many people propose that if you had cool environments or surface waters present at all, really, that was the key ingredient. It creates the opportunity to say, hey, well, we have all the key ingredients here. What's next?
That's Dr. Aaron Kavosi from Curtin University. And this is SpaceTime. Still to come, the Eclipse-making double satellite Proba-3 successfully reaches orbit, and later in the science report, more confirmation that the COVID-19 coronavirus, which created a world pandemic, originated in a Chinese lab in Wuhan. All that and more still to come on SpaceTime. The European Space Agency's Proba-3 spacecraft has successfully achieved orbit insertion following their launch aboard an Indian space research organisation PSLV-XL rocket. The flight from the Satish Dhawan Space Centre in Sriharikota on the Bay of Bengal coast had been delayed by a day due to technical issues with the payload. The twin Proba-3 platforms will perform precise formation flying down to a single millimetre in distance, acting as a single spacecraft to study the Sun's outer atmosphere corona and its solar wind, the constant stream of charged particles flowing out from the Sun. The close formation flying will allow the probes to create an artificial solar eclipse in orbit, thereby allowing prolonged views of the Sun's ghostly corona. Stacked together for the launch, the two satellites separated from their upper stage about 18 minutes after liftoff. The pair will remain attached together while initial commissioning takes place, overseen by mission controllers in Belgium. The spacecraft have been placed into a highly elliptical orbit which extends out more than 60,500 kilometres from the Earth's surface. Reaching this orbit required the most powerful variant of the PSLV XL 4-stage launcher, fitted with no less than 6 strap-on solid rocket boosters. If Proba-3's initial commissioning phase goes to plan, then the spacecraft pair will be separated early in the new year in order to begin their individual checkouts. The operational phase of the mission, including the first observations of the corona through active formation flying, should begin in about 4 months' time. Once the science phase of the mission begins, the Proba-3 occulter spacecraft will cast a precisely controlled shadow on the coronagraph spacecraft, flying around 150 metres away, producing solar eclipses on demand for up to 6 hours at a time. ESA Proba-3 mission scientist Joe Zender says there's simply no other way of achieving the observational parameters needed for the mission, other than having the occulting disk fly on a separate but carefully controlled spacecraft. Any closer and unwanted stray light would be spilling over the edges of the disk, limiting the vital close-up views of the sun's surrounding corona. Proba-3's principal investigator, Andrei Zukov from the Royal Observatory of Belgium, says that despite its faintness, the solar corona is an important element of our solar system, being the source of space weather and the solar wind. At the moment, we can image the sun in extreme ultraviolet in order to see the solar disk and the low corona, while using Earth and space-based coronagraphs to monitor the high corona. But that leaves a significant observing gap, from about 3 down to 1.1 solar radii. And that's the segment that Proba-3 will study. This will make it possible, for example, to follow the evolution of colossal solar explosions called coronal mass ejections as they rise from the solar surface and are accelerated outwards at high speed by the solar wind. ESA's Director General Josef Aschenbacher says Proba-3's coronal observations are taking place as part of a larger in-orbit demonstration of precise formation flying. He says the best way to prove this new European technology works as intended is to produce novel science data that nobody's ever seen before. It's not practical with today's technology to fly a single 150-metre-long spacecraft into orbit. But if Proba-3 can achieve the equivalent performance using 2 small spacecraft, then this mission will be opening up new ways of working in space. This is SpaceTime. And time now to take a brief look at some of the other stories making news in science this week with the Science Report. The United States House Oversight and Accountability Committee's COVID-19 panel has confirmed that a lab-related incident involving gain-of-function research at China's Wuhan Institute of Virology was the likely cause of the COVID-19 pandemic. The highly detailed 520-page report followed 2 years of intense investigations and over 1 million pages of evidence. It ridiculed suggestions that the virus emerged in nature and then somehow jumped from animals to humans. The report concluded that the weight of evidence increasingly supported the lab leak hypothesis. The FBI's director, Christopher Wray, had previously said that the agency assessed that a leak from the lab in Wuhan caused the COVID-19 pandemic. And similar conclusions were reached by the United States Department of Energy, the State Department, and the Director of National Intelligence. The House report found that Wuhan is home to China's foremost SARS research laboratory, which has a long history of conducting gain-of-function research under what most scientists would regard as inadequate biosafety precautions. It also pointed out that the researchers at the Wuhan Institute of Virology were infected with COVID-19 in the fall of 2019, months before it was discovered in a wet market in December of that year. The report also slammed the New York non-profit EcoHealth Alliance for using United States taxpayer dollars to facilitate gain-of-function research at Wuhan. And it slammed the Biden administration for deliberately spreading COVID-19 misinformation by wrongly claiming the lab leak was just a conspiracy theory. The report specifically singled out former White House Chief Medical Advisor and National Institutes for Health Director Anthony Fauci for pushing back on the lab leak theory and trying to discredit it. The World Health Organization says over 7 million people have been killed by the COVID-19 coronavirus since it was first detected among workers at Wuhan Institute of Virology back in September 2019. However, the Lancet Medical Journal estimates the true death toll is likely to be above 18 million, with some 775 million confirmed cases globally. Scientists have documented the collapse of the Conga Glensa Ice Shelf in East Antarctica in 2022, charting its slow collapse over a quarter of a century. A report in the journal Nature Geoscience identified 4 main stages in the ice sheet's retreat that started around 1997, when it first became separated from the nearby Shackleton Ice Shelf. It then slowly got smaller and smaller over time, losing about 10% of its area over the next decade. In 2011, it broke away from the central point that was pinning it down, and its ice loss then accelerated to 10 times the speed, losing some 10% of its area in just 1 year. The remaining parts of the ice shelf then disintegrated over just a few days in 2022. The authors say these new observations shed light on the process involved in an ice sheet's collapse, especially the impacts of ocean and atmospheric warming and extreme weather events. Well, after 60 years of searching, geneticists have finally identified the genes behind the marmalade coloration in some domestic house cats. A report in the journal Science says the orange colour is likely the result of a missing segment of DNA in a non-protein coding part of the cat's genome. Researchers discovered cat skin cells from which orange fur sprouts express 13 times as much RNA from a gene called UTHGAP36 compared to skin cells from cats which don't have orange hair. Expecting to find the protein coding section of the overproductive gene had mutated, the authors were surprised to find that the sequence preceding it had instead contained a deletion affecting the rest of the gene's expression. They found this same deletion was present in every single orange cat they examined. And they looked at a database of 188 cats, which included 145 orange cats, 6 calico tortoiseshell cats, and 37 non-orange cats. One finding didn't come as a surprise. As long predicted, the mutated gene was located on the cat's X chromosome. And that explains why the orange colour appears so differently between the sexes. Most orange cats are male, while most female cats with some orange fur in them end up with patches of different colours. So it all makes perfect sense. Do you ever get the feeling you're being watched? Well, you're not alone. Turns out, between 68 and 94% of people believe that this sensation is caused by their bodies somehow knowing that they're being looked at. But Tim Mendham from Australian Skeptics says, in reality, it's just a simple way of comforting ourselves that we have some sort of instinct that will protect us against being watched by people we'd rather weren't looking at us.
The answer is there's no scientific proof to it, and certainly no that when you really experiment with it, it doesn't work. And there's various articles that come out talk about it. We've had an article with a wonderful experiment that a teacher did in a school where he sat 3 or 4 kids out of the front of the class facing the wall, so away from all the students. Each of them had a bucket on their head. It was a pretty basic experiment, low cost, and had a number on it.
I think my teachers wanted to do that with me on numerous occasions.
But anyway, he got the rest of the kids in the class to sort of say, pull a number out of a hat, didn't tell them, and said, everyone stare at that number. And then the people with the buckets put their hand up if they thought they were being stared at. They found out they weren't. 1 in 4 chance of being successful, and they had pure 1 in 4 chance results. So there was no indication that you can really be seen. Someone suggests that if you turned around because you think someone's looking at you, well, that movement might encourage someone to look at you. Why did that person spin around, and very quickly they can turn their head towards you. So when you finally finish your twisting, there they are looking at you. So
and the person being looked at thinks, why is he looking at me?
That's right. The answer is no. There is no evidence for it. Tests have shown it doesn't work. And even though a lot of people believe it, that it does, this curious one story said between 68 and 94% of people believe that it's caused by someone knowing that they're being watched. And why 68 to 94 is a really weird number.
Numbers? Yeah.
I got no idea where those numbers come from. People can believe things. That doesn't mean they're actually true, surprisingly.
That's Tim Mendham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.